There's something unsettling about the idea of sending a message into space, and not knowing who, or what, might hear it. In 1977, humanity launched a machine designed to explore the outer edges of our solar system. A silent traveler. A mechanical witness. A probe carrying the sounds of Earth into the unknown. That machine was Voyager 1. At the time, no one expected it to last this long. Its mission was simple: study Jupiter. Study Saturn. Send back images. Then fade into silence. But that's not what happened. Voyager 1 kept going. Past the planets. Past the heliosphere. Into interstellar space, the region between stars. Today, it's the most distant human-made object ever created. A relic of 1970s technology, still whispering data back to Earth. And for decades, that data has been predictable. Weak. Fading. But understandable. Until recently. Because something changed. Not dramatically. Not in a way that made headlines overnight. But in a way that made scientists pause. It began with noise. Not unusual in deep space communication. Signals degrade. Interference happens. Background radiation distorts transmissions. But this noise was different. It wasn't random. It had structure. At first, engineers assumed it was a processing error. A glitch in decoding. A problem with aging hardware. After all, Voyager 1 is nearly 50 years old. Its systems were never designed to operate this long. But when they reanalyzed the signal, the pattern remained. Repeating. Consistent. And most importantly, unexpected. The anomaly appeared in data from Voyager's plasma wave instrument, a device designed to measure vibrations in interstellar space. Normally, it detects subtle changes in charged particles. The sound of space translated into data. But this time, the signal didn't behave like natural plasma waves. It formed intervals. Rhythmic bursts. Almost like pulses. Not strong enough to suggest a transmission. But too ordered to ignore. That's when things became uncomfortable, because in science, patterns matter. Random noise fades. Structured signals raise questions. And this one refused to disappear. At NASA's Jet Propulsion Laboratory, engineers began comparing the anomaly against known sources. Solar activity? No match. Background radiation? Didn't fit. Instrument malfunction? Possible, but unlikely. Because the pattern repeated across multiple datasets. And that changes everything. Now, to be clear, this wasn't proof of contact. Not even close. But it was something else. It was unexpected behavior, in a region of space we barely understand. And that alone is enough to trigger deeper investigation. Because Voyager 1 isn't just another spacecraft. It carries something unique. A message. Attached to its side is the famous Golden Record, a phonograph disc containing sounds, music, and images from Earth. Designed as a kind of time capsule. A greeting to whatever might one day find it. Most scientists never expected it to be discovered. It was symbolic. Philosophical. Almost poetic. But now, with Voyager drifting through interstellar space, and anomalies appearing in its data, some are beginning to ask a quiet question. What if the message wasn't just sent? What if something, somewhere, noticed? That doesn't mean aliens. It doesn't mean contact. But it does open the door to possibility. Because interstellar space isn't empty. It's filled with magnetic fields. Particles. Shock waves from distant stars. Remnants of cosmic events we don't fully understand. And Voyager is moving through all of it. So what if this signal isn't artificial, but something we've simply never observed before? A natural phenomenon that just happens to look structured? That would still be a discovery. A major one. Because it would mean the space between stars is more dynamic, more complex, than we ever imagined. But there's another possibility. One that scientists approach carefully. Because extraordinary claims require extraordinary evidence. And right now, we don't have that. What we have is a mystery. A faint signal. A repeating pattern. A question without an answer. And a spacecraft, still traveling deeper into the unknown. Further than any human-made object has ever gone. Still sending data. Still listening. And maybe, still discovering, not everything in space follows a predictable path. Planets orbit stars. Moons orbit planets. Comets swing in long, repeating arcs. Even chaos has patterns. But sometimes, something appears that doesn't belong to any system we understand. Something that doesn't orbit our sun. Doesn't follow a familiar trajectory. Doesn't come from anywhere we can easily trace. In 2017, astronomers detected exactly that. A faint object, moving fast, cutting through our solar system on a path that made no sense. It wasn't bound to the sun. It wasn't slowing down. It was just passing through. They named it Oumuamua. A word from Hawaiian meaning, a messenger from afar, arriving first, and at first, it didn't seem extraordinary. A small object. Likely a rock or comet. Something ejected from another star system millions, or even billions, of years ago. But then they started studying it. And the story changed. Milky Way. What made it so strange? 7. The first surprise was its shape. Most asteroids are irregular. Lumpy. Uneven. But this object appeared to be extremely elongated. Possibly cigar-shaped, or even flattened like a pancake. Either way, it was unlike anything we had clearly seen before. Then came its motion. It wasn't just spinning. It was tumbling. Unstable. Chaotic. As if it had been disturbed by something long ago and never settled. But the most puzzling detail came next. As Oumuamua moved away from the sun, it sped up. That shouldn't happen. Objects passing through the solar system are affected by gravity. They slow down as they climb away from the sun's pull. But this one showed a slight acceleration. Subtle. But measurable. Enough to make scientists stop and ask, why? Brain theories and tension. At first, the explanation seemed simple. Comets release gas when heated by the sun. That gas acts like a tiny thruster, pushing the object forward. So maybe Oumuamua was a comet. But there was a problem. No visible tail. No detectable outgassing. Nothing that clearly explained the acceleration. That opened the door to more unusual ideas. Some scientists proposed that it might be made of exotic materials, like frozen hydrogen or nitrogen. Substances that could evaporate without leaving obvious traces. Others suggested it might be incredibly thin. Lightweight. Almost like a natural sail. Pushed not by gas, but by sunlight itself. And then, there was the idea that caught public attention. Not because it was proven, but because it was possible. That Oumuamua might not be natural at all. That it could be artificial. A fragment. A probe. A piece of technology from another civilization. Most scientists rejected this. Not because it's impossible, but because there's no evidence. And in science, evidence comes first. Speculation comes second. Still, the fact that the idea was even discussed says something important. It shows how unusual this object really was. Telescope. Watching the unknown as Oumuamua continued its journey, telescopes around the world tracked it as long as they could, including powerful observatories like the Hubble Space Telescope. But it was moving fast. Too fast. Within weeks, it was already leaving the inner solar system. Fading. Becoming harder to observe. And eventually, it was gone. Disappearing back into interstellar space. Leaving behind something unusual, not answers, but questions. Shooting star. Why this matters. Oumuamua wasn't just a strange object. It was the first confirmed visitor from another star system ever detected passing through ours. Which means something profound. Interstellar objects are real. They exist. They travel between stars. And sometimes, they pass right through our cosmic neighborhood. That changes how we see space. Because it means our solar system isn't isolated. It's connected. Part of a larger environment where material moves between stars. Where objects drift across unimaginable distances, carrying information about places we may never reach. And maybe, just maybe, they carry more than that. Link the connection to Voyager. Now here's where things get interesting. Because while Oumuamua was passing through our solar system, Voyager 1 was already far beyond it. Drifting in interstellar space. Two different objects. Two different origins. Both moving through the same vast region we barely understand. One arriving. One leaving. And both reminding us of the same thing: we are not isolated.